Let's start with the question, are we going to crash into the mill? Look at those Z-min values. I've got 3 tools now for this operation. Tool 1, Tool 12, and Tool 31. Tool 31 comes the lowest, and in this case my Z-min values are positive, so I'm looking for the lowest positive value, and it's here. 0.3719 inches up from the top of the parallels, up from the bottom of our part. Remember how in Fusion, this probe is going to come down to here to find your part with precision. So let's confirm that we can actually do that in the mill without crashing into anything. Call up the probe and handle jog it down until it's close to about the height that you can see in Fusion. Then look at your Z position in your personal work coordinate system and get it exactly to that Z-min value, 0.3719. And if your numbers are slightly different here, that's less important than your understanding that you're not going to crash into the vise. So work with the helper, ask questions, and feel good about how low you're going to go. And here, it looks great to me. I'm not going to crash into the vise, and I am going to get under that rough part of my stock. I'm going to get down to the machined surface that I'm trying to make contact with later in my program. All right, now just use the same strategy that we've been practicing every other time we press cycle start. Slow down the mill, slow down yourself, pause often with the feed hold button, ask questions, creep up on your first contact moment, check in with your position screen, immediately hit feed hold if you hear any sounds or see anything that you don't fully understand. Like here, one of my parallels shifted underneath my part in the middle of the cut. That would require a judgment call about whether to proceed or to reset. And pause everything more fully by turning off the coolant and stopping the spindle and opening the door and leaning in for key moments of the journey, especially when it's your first time cutting a new sort of cut. And here, the newest thing we've got going is this initial clear of material, leaving 10 thou of overhang that we can slip the probe under. The goal is never to cut metal as fast as we can and get it done with already. The goal is to learn as much as we can about each of these awesome moments in the machining journey. Like how magical it is that we've got this laboratory environment where we can find geometry with precision and bring these high force cutting tools back into plane with things that we cut when our part was upside down. Even something as simple as how the chamfer tool finds its way right to the edges of the top of your part is pretty special. When the program is complete, blow off the coolant and take your part out of the vise and look at it with your eyes, with your fingers, with your fingernails, and under the microscope. Take note of every physical artifact that you can and see if you can imagine what might have caused it to result in this way. And if you're in the mood for celebrating where you've gotten to, great, do so. It's a lot of work. Show it to somebody who doesn't know how to do this sort of work. See what sort of questions they ask. See if you can have any initial ideas for how to make our biggest blemish, this visible seam, go away. And though you might be tempted to run outside and pronounce your accomplishment from the nearest mountain, take one moment and clean out the mill. Get your parallels out of the vise and blow them off with compressed air to get that coolant off. It's a real pain when they go back in the drawer wet. They get really sticky. Once they're back in their home base, take a look around your workstation and clean up any remaining rubbish, and then remember all the way back to our turning on the mill video and get your coolant hose set up to be able to wash off the table. Wash these chips out of the vise and off the table and down into the coolant trough. Congratulations. The mental gymnastics, both in Fusion and here at the physical mill, involved in setting up an operation 2 where you flip everything upside down is no joke. Now that you can do it, it opens up a whole range of possible geometries that you can make here at the mill.